All right. Oh my god. After a couple sessions of failed recordings, I'm back to streaming. That was terrible. I just spent like a couple of hours trying to record a video and it was impossible. It was absolutely impossible. So I decided I'm gonna stream it instead because that's easier, right? Anyway, this is gonna be a weird discussion and topic because like obviously not all people are gonna experience this, but it is happening. That's the weird part about it. And I've demonstrated it multiple times on stream, but apparently like not enough people are getting the info. But now apparently game developers have started pushing out mandates for stability issues or solving stability issues with the Intel CPUs specifically for like reducing the boost frequencies and potentially like limiting your CPU. This is becoming like more of a widespread topic, especially on 14th gen. The problem about it is there's so much information to cover because it's not clear cut. It's not as simple as, oh, I got a bad CPU, oh, I got a good CPU. It's not as simple as that. You need to go a little bit deeper, and the topic could be hours and hours long if you want to demonstrate all of the potential causes and what kind of issues can occur, how they can occur, how can you start noticing these issues, and what components suffer from this the most. Right? I'm gonna try to go over this as thoroughly as possible, and I feel like it's gonna be like quite a chunky part. Also, yeah. Welcome. The main point about this is going over what kind of components suffer from this and like how it starts happening, and then how you can potentially reduce the risk or completely eliminate the risk of degrading your CPU or like starting to experience the issues that can occur. And then what are the drawbacks of setting the limitations? How much performance do I lose? Is it even worth it at that point going for like an i9 or an i7, right? So we can go over that. I might introduce one more test to that because I kind of like it, and it's Handbrake. Handbrake, I like Handbrake. It's like a real world stress test, right? So it kind of shows you what kind of all-core performance you might expect. And it's also like one of those workloads where the CPU, if it is degraded or if it's unstable from the factory, it's probably gonna fail in that workload. So that would be kind of like a good demonstration. But first I need to go over what kind of components I'm actually using. So you get an introduction to the system and then we start testing, right? And then I can also show a bunch of situations where I came across instability on i7s, i9s, and also a comparison between Z790 and B760, for example, from a previous stream, which was that was a beefy part as well. Those like what, 8 hours or something like that. It was an incredibly long session, getting all the stress tests in and all the performance benchmarks and everything. So yeah, let's get started. That's a short introduction to like what the first part is gonna be. First, let's get over the components, right? As you can see, actually you can't see that, but I'm on a Z790 Apex Core with BIOS 0081. This is a beta BIOS, pretty much the latest one to be honest. I'm on a 14900K, so like worst case scenario, right? Most CPUs that are failing or being unstable or degrading rapidly are the i9s. That's the most noticeable one. All right, next, this is a setup BIOS, right? It's fairly set up. It is disregarding the official Intel limits because I know that my CPU, my personal CPU, this is capable of running all the stress tests and benchmarks and everything without crashing, even with a slight increase to the thermal velocity boost, right? Apart from that, it's completely stock in terms of CPU, right? So we have AVX, offset is 0, DRAM timings, I can go briefly over this. It's just everything set on 8000 with timings. DG Plus, here you can see pretty much everything on auto. So it's following ASUS default options. Then we have internal CPU power management. I limited the CPU to 100 degrees here. So we just max out at 100. I don't think we're gonna be maxing out at 100 actually because my CPU is, it's OP. But most of the i9s are going to be just pinned at 100 if it's power unlimited. Here you can see current limit. unlimited and power as well. There is no IAAC load line, and CEP is disabled, right? And I'm gonna be showing IAAC load line with the current limit a little bit later. As you can see there, the third thing is 288 limit plus 0.7 AC load line. That's roughly what a B760 motherboard will set, roughly. Not exactly, but it's gonna be somewhere around that mark. Thermal velocity boost, as I said, it's a little bit enhanced. So we have voltage optimization that's gonna drop both boost and all-core workload voltages. It's gonna drop it a little bit. And boost target is 6 GHz and temperature offset is 10 degrees. It's gonna try to sustain the boost frequencies a little bit harder depending on the temperature, right? Everything here, basically no options were applied or anything like that. Here you can see the SP score. I don't think I have the MC, sadly. No, I don't have it trained. I think the MC should be like around 81 or 82, something like that. Here you have the SA voltage. That's pretty much one of the only things set on the CPU. RAM voltage, and then also VDDQ and MC voltage here. Everything else in terms of CPU is stock. All E-cores enabled. All of this is stock by motherboard spec, right? ASUS motherboard spec. All right, we can quit and go into Windows and start testing. And we can discuss a little bit like what's going on. So at first, obviously, it wasn't that obvious that the CPUs were experiencing instability issues because they were new on the market. It took a little bit of time to actually start experiencing it, and once it started happening, it was pretty rapid for us at least, because we've had quite a lot of i9s and i7s, and to be honest, for some samples it happened within hours, right? But it was kind of unknown what stress tests to run, because the hard workloads actually did not crash the CPUs. That's the interesting part. The hard workloads basically pinned the CPU at 100 degrees and it started thermal throttling. Now we all know that the frequency to V-core ratio is not linear, right? It's not a straight line. You progressively need more voltage for every 100 megahertz higher, for every multiplier higher, right? So obviously once it starts downclocking, it's not going to require that voltage anymore for sustaining stability. So under hard workloads pinned at 100 degrees, it's actually going to be more stable than just light workloads, for example, like shader loads or something like that. And that's exactly where people are experiencing the instability. When the shaders of a game are loading, or when the game is loading or something like that, right? That's not limp-pack hard, right? That's fairly lightweight on the CPU, so it's going to be boosting higher, right? Now, eventually, I came across R15 and R15 Extreme, and these two are actually extremely hard to run on 14th gen, specifically on the 14900K. Yeah, similar to PBO instability, it's very similar, yeah. But it feels like this here is more of a hardware degradation issue more than like the over boosting on AMD parts, right? AMD parts, unless you had it like all core overclocked for an extended period of time, then you started degrading. But if you kept it stock, right, completely stock limits, then the AMD CPU usually did not start experiencing this kind of instability. Here it's happening literally at stock settings, right? Because this is to the limit on stock. Yeah, but also the interesting part is we've also had a lot of 13900Ks and KSs, and to be honest, I did not get a single unit that would be experiencing this kind of instability. Now, to be honest, at the same time, I was not running R15 Extreme or R15 or these kind of stress tests that crash the system on 14th gen, because it is like I said, it's a developing discussion. We are finding out about this, right? And it's good to share as much information as possible, right? So people are aware of this and they can test for themselves. And this is all freeware. You can download this and you can run R15 Extreme on your own. No problem, right? A lot of this stress testing software is free. A lot. Not all of it, but a lot. So you can test for yourself, right? Now with 14th gen compared to 13th gen, with 14th gen, this is common, right? Which is kind of scary. You don't want like every second or third 14900K to experience this kind of instability, especially new from factory. And how are you supposed to know it's gonna be like degrading, or if it's even unstable from the factory, brand new, if you're not even aware that it's happening and you're not even aware what kind of stress tests to run? You're just gonna try to run your game and your system is gonna, like, your game is gonna fail, or you're gonna blue screen or something like that. And you're gonna be sitting there like asking yourself, what the hell is going on? Does Intel CPU degrade if you push the cache ratio higher than 50? I have no idea. Probably, maybe, who knows? You need to put it through, you potentially need to put it through some serious stress to experience that. And obviously every CPU is gonna be a little bit different, because like my CPU has been abused to death and it doesn't experience these kind of issues, right? I bet there wouldn't be as much people complaining mobile manufacturers in default to unlocked PLs. True. Manufacturers are not following the Intel spec. A lot of them just completely ignore it because they want their motherboard to be on the top of the charts, right? Obviously. Some of them do. Some of them do apply the PL2 and PL1 based on Intel spec. But in my opinion, for i9s and some i7s, even that is a little bit too loose. Personally, I would actually limit it quite a bit harder. Now, we are gonna see the impact, like it says, the impact of current limit, right? We're gonna see the impact of current limit. Now, the interesting one, I think, is gonna be CPU-Z, because it's gonna show you single core and all core workload, and that's where the interesting part is gonna be, right? And I think the argument for using a current limit is justifiable in that specific one, right? And to be honest, if you're going to be running all core workloads all day like this, right, at unlocked power limit, then like, what the hell are you doing? You might as well like limit, so you limit your power consumption and you can extend your lifespan of your components, obviously. I want you to push the cache ratio on. I don't. I leave it stock. So i9s are going to be between 45 and 50, I believe. Clocks don't matter for degradation. Yeah, but if you set it... Okay, so clocks don't matter for degradation. If you mess with it manually and you don't consider all of the factors that come behind it, so for example, like you're trying to push core clock or cache clock or E-core clocks or whatever, the motherboard is going to do its own thing, dealing with the voltage and regulation, everything like that. So at that point, yes, you are... the clocks do matter, right? But yes, like you said, in a vacuum, like the clocks themselves don't really matter for degradation, right? Now, keep in mind also, clock cycles do increase the current, right? So let's get that out of the way. If you're using the same exact voltage at 5.5 and 5.7, 5.7 is going to draw more current because there are more active cycles. So yeah, it is, like I said, it's a difficult debate, it's a difficult one. So let's start, right? Let's start, and we have our hardware info open right here. And we can do a CPU workload, right? Boom. And before this crashes on me now. No, if this crashes, oh my god, I'm pissed if it crashes, but no, it should not. Anyway, this is a normal highly binned deleted water-cooled 14900K like with TVB optimizations and everything. All right, apparently we scored a little bit lower. Why did this score higher? I forget. Was it an all-core overclock? It might have been. Anyway, apparently it scores this much. So let's adjust the text here. So we have the text on screen, so everyone can look at it if they show up after the stream started. So 1738. Now we go to R15. Now we can see that this passes. By the way, I'm doing these tests because I would assume that a lot of people are going to be actually looking at this. This is meant to be like a published part of the stream, right? So more people get engaged. And I'm running these tests mainly to allow them to know how to stress test their CPU and find out if it's experiencing the instability, right? So let me explain that a little bit. R15 Extreme and R15, if your CPU is unstable and if it's actually experiencing the instability, this test will crash within a couple of seconds of running, if not exactly when you start the test. Literally when you start and the first squares appear, it will crash. It will stop the test and you will not be able to close R15. The window will be just frozen. You will be able to move your mouse and you'll be able to open Task Manager and close the test. And you can actually just close it here and you can press delete and it's gonna close Cinebench. Right? That's how you get that test off screen. Also, I see why it scored lower. Wait, am I EC here? No. Okay, that's annoying. Hardware info is actually taking one of my threads, so that's why I scored lower previously. That's a little bit annoying. Well, Ripperoni. Oh, this is a different installation, that's why. The other one is stress testing a system right now. So yeah, it has this bug, sadly. But yeah, we're gonna follow this because we're not gonna change the installation, so the results are gonna be consistent. Right. All right. R15, so R15 and R15 Extreme are the two tests that show this instability the most, right? They are gonna instantly crash if you have an unstable CPU, especially when it's boosting. And this is mainly on 14900Ks. Some i7s, and I haven't had an i5 that has this. So like some i7s will also experience this, but i5 probably not. Like probably zero chance that an i5 is going to experience this. So 6450. Okay, here we go. And CPU Z now. CPU Z right here. SPD bench. All right, let's bench this. Oh my god, single core might be a little bit lower on mine because of the hardware info. All right, wait. You don't OC, dude? No, I don't OC. They're already unstable at stock. What is this title? I know, right? This is to get people engaged, right? This is to get people engaged and let them know. So what's the situation, right? Did I crash? Did hardware info crash? No, it didn't. Dude, hardware info is being annoying right now. Oh. Okay, let's rerun the tests. This is exactly why I don't do a recording. Oh, that's hilarious. Anyway, let's see this. All right. If I was doing a recording, oh my god, I would be cutting this video apart. You're just asking for issues at some point? Well, yeah, on the i9s and i7s, yeah. Yeah. That's also, so like when you set a current limit, you will not hit those frequencies to crash the CPU. And I can also demonstrate how you can actually bypass that and still experience the issues. That's another thing that I want to showcase, how to mandate like the frequency, or I should say boost frequency limits, right? That's how you mandate it. And it's kind of annoying. I know it sounds like, oh my god, I'm gonna be losing so much performance, but realistically, what are you gonna be looking at? Those couple percentages of performance, or are you gonna be like trying to use your PC as long as possible, especially if it's parts like this, which cost a fortune, right? I would take the second one. I would like to use my parts as long as possible. Now, if you're benchmarking and like pushing all the results to the maximum, sure, go and do that, no problem. You can still do it, just do not run your system like that daily. That is you're gonna be shooting yourself in the foot if you're gonna be doing that. Especially if you're a system integrator, right? If you're selling these parts, right? Obviously, you're gonna be shooting yourself in the foot with that. The people are gonna start coming back to you with unstable systems, and they're gonna be like, "What the hell is this?" And we've already had multiple people coming back to us with instability issues, so we had to obviously mandate that. We had to fix it. Will my CPU slowly degrade? Slowly deg. Well, if it's current limited, you reduce the risk. I will not say eliminate the risk because I still don't know. It's an evolving topic. But you reduce the risk in long-term degradation and potentially like the CPU getting unstable, right? 17489, 17489. LinX, all right. Oh, LinX, if I was using... So, I need to explain this one for people who don't know about this, if you're going to be using this stress test. If you don't have it, it's going to be pretty difficult to find, I think, especially if you're not in communities. But if you have a Z790, I think it's just Apex, the white one. It might be just the white one, but wait, the Z790i Edge also experienced this. But if you have a high overclock on your memory and you have a previous gen motherboard with a 13th gen or 14th gen CPU, let's say i7, i9 or KS, for example, you might experience an instant black screen when you run this. So like, there's my disclaimer. You might actually experience an instant black screen when you run this. Keep that in mind. Okay, okay, this doesn't happen on the Encore, so we can safely run this on the Encore, no problem. As you can see, it's a fairly power-hungry stress test. And I think this is actually throttling a little bit. So, go up. My cooling is pretty solid as well. All right. Okay, also another note. If it goes over 1000 gigaflops, the test will stop instantly. Now, this is a bug. This is a bug of this stress test, but if it goes over 1000, it's gonna stop instantly. So we hit 1037. This is a pretty healthy score, to be honest. VT3, now let's run a VT3. The problem is I kind of want to do it here because I don't want to run 2 minutes of it. LF3, opinions on LF3. Okay, relax, dude. I shared 2000 opinions on the LF3 yesterday. Just go watch the first 25 minutes of that stream and you're gonna get my opinions about it. This got a bit worrying, yes, but like I said, it's only recently that this news kind of started coming out, right? It was after a post on Twitter that kind of exploded. Everyone started talking about it. About Unreal Engine 4 and 5, whatever, games having stability issues. But yeah, this news started coming out, talking about the instability issues of these games. And the developers talking about reducing the frequencies of your CPU so they don't experience this instability issue. This is the post that exploded, right? And this is why I'm doing this stream, right? So like the news is slowly coming out because I was talking about this as well, like a month or months ago, that if this keeps happening, this instability, we are gonna get the news out eventually. Eventually the news is gonna come out and people are gonna be talking about it. And now the time came and the people are actually talking about it and acknowledging the issue, right? A is official ice for what? 245 is official? Oh my sweet goodness. That, ew, that's a lot, by the way. That you are heavily losing performance on that, by the way. I can do that as well. If it's official, I can do that as well. All right, VT3 second test, 1.40 on 10. Also, that's not the right marker. All right, that's also a fairly healthy number, and it's passing. I always find it funny when it's passing, because these settings are ridiculous on my system. Anyway, as I can see it clearly, R15 score, R15 Extreme score, CPU-Z score, LinX score, VT3 score. Is there any other scores that you might be interested in, or I should move on? Because I can just go back into BIOS and set the limit. Which, me personally, I think the 288 amp limit is perfectly fine. Wonder how 1000 watt server CPU and GPU will go on Unreal Engine? They're big. Yeah, I can't imagine. I can't imagine how that's gonna go. Anyway, even without any OC, yes, even without any OC, mainly because manufacturers, board manufacturers, do not follow official Intel spec. They will unlimit the power of the CPU, most of them, and you will experience this at stock, complete stock. Yeah. That's the kind of scary part. That's just great. I know, right? I know, and the news just started exploding. So, might as well do it. Might as well share as much information I can about this. Right. So internal CPU power management. Right. Now we can start doing the limit, and I can demonstrate what kind of performance. Ooh, I didn't do the handbrake thing. Do I do the handbrake thing? Are you interested? Are you interested in the handbrake? So like how the rendering will be affected. So let's say you're using your PC for rendering workloads and so on. ICC max for stress test is 307. For daily use, 245. Does that actually say in the docs? Is that in the docs? Yes, okay. For stress tests. How does a CPU determine what is a stress test and what isn't? Thank you for the link, by the way. 13th generation. Oh my god, that's a lot of information. Oh no. Okay, you are crazy for finding this, by the way. At least Intel is kind of transparent in terms of like when it comes to like the nitty gritty of their chips and technology and whatever. They're actually pretty transparent. They're gonna tell you like all the details about it, like how this works, what it is, what it does. That's pretty cool. Crazy for finding this, by the way. That's cool. Page 184. Page 184. 184. Processor VCC core active and idle mode DC voltage current specifications. Oh, that's S&S refresh. Ooh. Now, here's the interesting part, right? I can show this on stream as well. Oh my god, we're gonna extend the duration of this stream a lot. I'm just gonna quit and gonna put the rendering workload, so like the handbrake thing, I'm gonna put it on. That's gonna take a couple minutes to do. And then when that's over, we can continue with the current limit. Meanwhile, while that is going on, I can actually go over the docs. Did you read that whole PDF? No, you don't have to read the whole PDF. You can look at the menu info, and I can also show you Task Manager, because like, you're gonna see like how the memory behaves in Task Manager when you load this thing. And what I do is for this stress test, what I do is I go to preset and I scroll down all the way to production max. This is a 8K 60 FPS video of Crysis. It's like 300 megabytes big. Here it is, 340. And all I do is production max everything out. Basically, if you go over the settings here, everything is maxed out for production. And all you do is literally start the test. That's it. You start it, and you pray that your system does not instantly close, because it is a heavy stress test. So, all right, it did open the docs. Okay, I can reduce the size of this. Okay, so if we have a look at this operating voltage, that's the first thing that's kind of funny to me, right? The operating voltage, the safe operating voltage maximum is 1.72, which is kind of ridiculous, but at low loads you can kind of understand it, because low loads they're going to be fine at this kind of voltage, but still kind of funny. So apparently, yeah, maximum processor, 8 P-core and 16 E-core is 307 amps. Note 1, I wonder what this is. Unit amps, of course. Ah, I see where the 400 came from. As maximum processor, extreme config. So, yeah, this is depending on what kind of config it is. Scroll up, you have explained ICC app. Okay, is less than user realistic applications. P0 and max and TJ max. For at least 10 milliseconds. So it doesn't state for how long. It doesn't say for how long you are able to run these kind of currents. That would be an interesting specification if they would say, like, so this extreme config 400 amps, you are allowed to run this for a certain period of time, right? Until it has to go down to let's say 320 or 245 or something like that. But I wonder what this means, by the way. 150 watts. Electrical specification. Six P-core and 8 E-core. 200, okay. Actually, this is an i5, right? On i5s, I personally use 192. 192, that's what I use. Yeah. Eight, this is a previous gen i7. This is previous gen i7. This is the current gen i7. 231, 160? No, this is like wait, no. This applies. These do not. These do not. Wait. Oh, I get it. What this means? Right. This just shows the official PL2. Is it called PL2? Of the CPU. So for example, like the i9 is 125 watts. And the upcoming KS is 150 watts. But yeah, if the motherboard manufacturers would follow the official Intel spec, these CPUs would be completely fine. But they are not following it, so they're not fine. I would assume these are for CPU to not degrade under stock clocks during a 3-year warranty. Yes, I would assume so as well. Apparently, we finished the test here. Now let's check Q, and you can click on this and see statistics. Wait, you can't see because I'm a stupid moron. There, so you can see Q right here, right? Q. You can click on the test and then you go to statistics and then you can see how long it took. 5 hours and 45 hours. This is why I don't make videos. 5 minutes and 40 seconds. 5 minutes and 40 seconds. 5 minutes 40. All right, now we can move on. Now this is, like I said, this is a real life workload. And as you can see, my CPU passed this perfectly with an unlimited power and thermal velocity boost. If you're watching this and you have an i9 or an i7 14th gen, I would encourage you to actually try this and see if your CPU is capable of running it. And you can also use hardware info to monitor your sensors, just like I am. You can open graphs by double clicking the sensors. So if you want to censor your maximum CPU temperature, you double click it and there's a graph that appears. So that's much, much easier to follow than just numbers that are appearing on hardware info. So it gives you a graph and kind of, you can follow it along. And you can see like misbehavior and something like that, for example. All right, let's limit it. 288. Benchmate. And let's see the behavior, right? So R15. Let's run this. Boom. And as you can see, even though I've set 288 amps, we do not actually get over 300 watts of power, which you would calculate over 300 watts of power right here, right? You would calculate, this is on die voltage 1128. So if you would calculate that, it would be 288 times 1.128, and that would give you the power number, right? That would give you 325 watts roughly. We did not get 325 watts. We got 240. So yeah, the power numbers do not correlate like they would on paper. All right, let's write this down. So 6150. 6150. Let's calculate that. So calculator, and let's see how much performance we lost by limiting this CPU to 288 amps. So divided by 6150. We lost 6%, about 6% in R15 by limiting the power, but we reduced the power. What was the power number before? It was like 300 and something. We reduced it by an incredibly larger amount, right? The power numbers went way down. The score did not go way down. There we go. All right, let's follow this one. This one is about the same voltage, also the same power. Also, I kind of want to demonstrate that different kind of loads will result in different kind of power readings, right? So now the score is 1647. 1647. How much did we lose? Calculator. We lost 1745 divided by 1647. We lost exactly the same. We lost about 6%. So R15 and R15 Extreme lose about the same amount of performance. Next up is CPU-Z. Stress CPU bench. It was 310 earlier. Yeah, so like 310 versus 240 watts. There was a massive decrease in power. So the very interesting part, even with a current limit, that's why I said at the beginning, almost 1 hour ago, the CPU-Z stress test is going to be interesting because it shows single core performance, and the single core performance right here is 980. The all core is 16452, and if you look slightly up, you're gonna see the previous CPU-Z score, which was 975 single core. So you can see that setting a current limit does not linearly reduce your performance across the board. It reduces your performance in all core workloads. What kind of performance loss did we experience with CPU-Z? In all core. We actually scored better single core now, which is kind of like ridiculous. 17489 divided by 16452. 452 is, we reduced about 6.3. So it seems like we're hovering around 6% performance loss with the power limit. All right, let's continue. Next up will be LinX. LinX, we can kind of expect this to drop quite significantly. We're gonna see. All right, so this is a very heavy workload, so let's see how much performance loss we experience in this. Discord app, what is that? That's what Intel says about TDP. Processor base power. The time averaged power dissipation that processor is validated to not exceed during manufacturing while executing an Intel specified high complexity workload, probably LIMPAC. Base frequency at the junction temperature as specified. What's the junction temperature, by the way? In the datasheet for SKUs, segment and configuration. So we experienced like 940 gigaflops. How much performance did we lose? Previously, calculator, 0.37, right? 37, yeah, divided by 940, and I can assume, yes, okay, so in a heavy workload, we experience a much larger performance degradation, or like performance drop compared to an unlimited power, right? This is expected because we are pushing an incredible amount of current through the CPU, and we're applying a current limit, right? So it's not going to exceed that. We lost about over 10% performance in here compared to an unlimited power. But again, previous power was 360 watts. If I'm not wrong, I saw about 239, 240 here. So if you compare the power numbers, or even it was like 370 watts divided by 240. There's no way. Wait, no. I'm talking the wrong way. We reduced the power by about 25%, because 55% here that we are seeing, this is an increase of power. So from 240 watts to 370 watts, this is a 55% power increase, right? But if we're talking about power reduction, this is 25% power reduction, right? For what, 5% performance loss. Because we were also calculating the performance increase, not the performance drop, right? When you are dividing a higher number by a lower number, you are calculating the performance increase from the lower number to the higher number. It doesn't go the same in the opposite way. All right, next up is VT3 17, 4 and 30. Yes. All right, let's see how much performance loss we experience in VT3, because it's becoming a fairly popular stress test. Also, this is kind of crazy. 220 watts, okay. So apparently, oh my God, VT3 is pushing a lot of current through the CPU. You can see the voltage. Voltage is under 1.1 volt. What kind of sustained frequencies are we looking at? Barely over 5 gigahertz. Here we have 1.26 to 10. 1.26 to 10. But the problem with this one is I can't just calculate the performance difference by typing in 140 divided by 126. But I guess, wait, I'm gonna wait for the second one. Yeah, okay, so 128. Let's go 128 because I followed the second one on the previous one as well. So calculator, we can still do it, but it's not relevant, I think. Divided by 126. It's 11%. Okay, so we can see that the heavy workloads, heavy current workloads experience a much larger decrease in performance than regular just all core workloads like Cinebench and CPU-Z and so on. Now let's find out about Handbrake. So like a real world workload. We can put this in here. Real world workload, let's find out, and you can just go down to production max and start. Let's have a look at this, and we're gonna be looking at it. Their junction temperature is 100 degrees. Okay, that's surprising. But I guess if that's by their spec, then I guess that's their binning process. So Panacos, this is only regarding 14th gen. I guess I should have stated specifically 14th gen. This is specifically for 14th gen. I'm still following the news right now, dude. There's more and more discussion about this, like ongoing discussion, because like people don't exactly know. Yeah, people don't know. Like I'm reading it right now. Someone just mentioned like 288 amps limits my CPU to around 170 watts and 5.1 gigahertz in OCCT CPU large. And he's like laughing, right? And the next guy is like, that makes no sense. 288 amps at 1 volt is 288 watts, which is on paper, that is correct. People don't know about this. If you current limit your CPU, your power is most likely going to be lower than the current limit itself. Now, I don't exactly know why that happens, because like it could be multiple things, including variation in sensor monitoring, because like we know sensors are not that accurate in terms of monitoring. They come close to the estimate, right? So they're estimating the thing, right? But it could also be a much deeper thing. For example, these components work on clock cycles. Now, when a clock cycle happens, there's a certain amount of power dissipated, right? But because these effective cycles are happening at such a rapid pace, you cannot accurately monitor the spikes and the dips. You can only do that with the oscilloscope and so on, right? But even that can be a little bit of variation, because how the hell are you going to be monitoring current going through a CPU? Like, you have to put the probes in between to monitor the current. You cannot do that, right? You can only do that by basically firmware software, and like voltage controllers can do that. And voltage controllers will estimate the power as accurately as they can, right? But they cannot operate at, like, let's say a CPU is operating at effective 5 gigahertz, right? You will not be able to monitor every single effective cycle. You're going to be able to monitor a bunch of them, right? So like, let's say your monitoring is happening at 250 kilohertz, for example. That would be ridiculous, by the way. But you're not even close. You're not even close to the effective cycles of the actual components. So like, it's extremely difficult. That's the first thing. It's extremely difficult to monitor the peaks, right? That might be the reason why we see lower power at a set current limit, because we might be experiencing very high spikes in power, or I should say current, but the average is going to be like sitting at a lower value, right? That might be one thing that's happening. Second thing that might be happening, and it depends where the load is happening in the CPU, obviously, and what kind of load, right? It depends what kind of load is happening in the CPU. So is it AVX? Is it non-AVX? Is it, let's say, Limpac or something else, for example, like let's say this rendering, or a benchmark like a R15 or something like that. So there are different loads that load different parts of the CPU, obviously. So the power itself is going to be varying, right? we can see here that it's about 220 watts, roughly. Now, if I load up Prime 95 non-AVX, I believe it sits around like 250, 260 watts, right? So the power is going to be going up and down, but at least I would assume that the current is going to be limited to 288 at least. I don't know exactly. I would need some seriously expensive equipment to actually be able to do that, and I can't. I can only show you what I can do, basically. All right, we actually finished. That's pretty cool. All right, let's find out. There we go. So 6 minutes and 11 seconds. What? Okay, so I didn't actually expect that. That's less time than I initially expected. So Handbrake, 6 minutes and 11 seconds. That's interesting. Because I have previous numbers of Z790 versus B760. This is I think my CPU is just way too good. I think it's way too good. It's ridiculous. So let's see a reduction in time, right? Calculator. So 6 minutes plus 11 is 371 divided by 540. That is 340. 9%. Okay, so it's slightly lower than the very, very heavy loads. So it's not quite an AVX intensive load, but it comes close. That's why I said when I was installing this and starting to run it, this is a very heavy workload. So if you have an unlimited CPU with an overclock even, for example, pray that it doesn't crash. Because this one is a heavy one. This one is quite up there. It's kind of like a VT3 or a Prime 95 or LinX or something like that. So Prime 95. Let me demonstrate how power looks like depending on what kind of workload you put on the CPU. Now I'm gonna read that wall of text before I do it. Yes, degradation, yes. Gen as well. 13th gen, not as much as 14th gen. 14th gen is more noticeable. Anyway, so like, let's see. Non-AVX workload in Prime. We can see the voltage, 1.074. The power is just scraping 240 watts. I can just straight up close this. Open it again. Prime 95. And I can disable AVX2 and run the same thing. Here we can see the power actually increased a little bit. Power actually went up a little bit. Temperature went, oh no, actually no, temperature is the same. But the voltage went down. So that means that we're pushing more current through the CPU. And now the AVX2, Prime 95, tank, boom. All right, here we go, 250. Oh, it was a spike. It was a spike to 250, and we can see the voltage decreased as well again, right? That means we're pushing more current through the CPU, or trying to push more current through the CPU. Do I follow the Intel spec 245 amps? Am I actually gonna start applying 245 amps to the to the motherboards and the setups? I kind of don't want to, I kind of want to keep it at 288. That was 288, and I think like 288 is... Ooh, I forgot to show you something. We're going to go back into Windows and I'm going to show you something. But I think 288 is like a good sweet spot, like a lower sweet spot for the CPU where you don't really hit the performance of the CPU that much. Now, we are specifically talking the i9. The smaller the CPU, the smaller the impact will be. Right? Obviously, an i5 is not going to be drawing as much current or as much power as an i9, right? i5 is probably not going to lose any performance at all at 288 amps limit, right? Those CPUs are not going to experience this, right? And i7 is kind of the same, right? i7 is slightly smaller. It's not going to draw as much current, so you will not hit the current limit as hard as an i9. i9 is a worst case scenario, right? But we saw a performance loss of about 10% in, or should say 11% in worst case scenario. And I think that's still kind of okay, right? You can live with that. You're kind of like, okay, so 10% loss, but at least my CPU is gonna be alive, right? If you're gonna go with an i7, the performance hit or performance loss is gonna be smaller, right? Obviously. But I want to showcase something. So what happens, I kind of want to do this to show that it's not so clear cut as it might seem, right? Because you might, let's say, set a limit, right? Let's say you have a CPU that experiences instability when it's completely unlimited all core, right? All core, completely unlimited, it experiences instability. Let's say you're trying to run R15 Extreme, it crashes, and then you set a current limit and your R15 starts running, right? Your R15 loads normally, finishes normally, everything is nice and stable, but you are still experiencing crashes, right? You're still experiencing crashes. Well, that's because the workload was all core workload. So all of the 8 P cores and all of the 16 E cores were working together, pulling all the power. That means that the CPU hit the current limit harder than it would if we only loaded, for example, let's say 8 P cores alone, right? Because the 288 amp limit applies to the whole CPU, not just the single or dual P core or whatever, right? So what happens is you will still experience the instability, and if you do, I would recommend running a smaller core workload stress test. So for example, like Prime 95, you can select the amount of cores you want to run, and in Y-Cruncher you can also select the amount of cores that you can run, right? So you can set, for example, small FFTs and you run it at full all-core workload, and you see this, right? And it runs, right? It runs normally. But then I would also recommend running Prime 95. Oh, actually, I should have looked. So actually, no, I should have just done it again. So Prime 95, you can monitor with hardware info, right? You can monitor this with hardware info. You go small FFT, all core workload, and you can see the effective frequencies of all the cores. Here we can see that the effective frequency of the P cores are hovering around like 4.95 almost, right? 4.95, let's say 4.95. Now we close this stress test and we run it again, and we adjust the amount of cores to stress test, right? And we set it to 8. And we can use hyper-threading, more stressful. Yes, that means that we're gonna load 16 P cores, ideally, hopefully. If your scheduler is broken, technically Windows 11 might mess with this a little bit. But if your scheduler is working properly, this should run on the P cores alone. It should not run on the E cores, right? So let's try to run this and monitor the effective frequency. As you can see, we are much higher power, much higher temperature. We are pretty much hitting the thermal limit here almost. And the P core effective frequency is 5.7 almost. That is the difference between the all core workloads and specific core workloads. That's why you might still be experiencing crashes even though you've set a current limit. That's exactly what might be happening if you're still experiencing instability. Because a lot of the stuff, because of the scheduler and everything, a lot of the stuff is not going to be using your whole CPU. A lot of the stuff is just going to be using single cores, maybe multiple cores, but mainly P cores, right? Your P cores are going to be boosting all the way up to 5.7, 5.6, depending on what CPU you have, obviously, and what kind of cooling, if you're hitting a temperature limit or whatever. But if you're not hitting a limit, your CPU is going to be boosting to the max possible frequency, even though you have a current limit set, right? How do you solve that, right? How do you solve that? Well, you will have to adjust your P core frequency or P core boost frequency in BIOS. That's what I wanted to show, right? All core workload does not mean, all core workload stability does not mean single core workload stability. That's far from it. Far from it. As you can see, like much higher power, much higher temperature, but also much higher sustained frequency on the P cores. If we completely leave alone the E cores, right? That's where you experience most of the instability. You can set this in BIOS depending on what kind of motherboard you have. You can set this in the BIOS. Usually they have it pretty easily set, right? So you can set it easily. For example, Asus, you might just go down to thermal velocity boost, right? Thermal velocity boost, and you can go down to boost until target. Now on unstable CPUs, I usually set a frequency of about, well, depending on what kind of CPU it is, I usually set between 5.3 and 5.5 gigahertz. Now on very unstable CPUs, I just set 5.3, right? 5.3, and that's it. Now Gigabyte has it a little bit differently. You need to set it per core, right? You need to set per core boosting. That is in advanced CPU settings. MSI, you can adjust the turbo ratio in the main menu, or turbo offset even. You can adjust the turbo offset in MSI, and you can do a negative offset, and it will show you exactly what kind of negative offset it is. Different motherboards like ASRock, for example, that's another one. I don't know exactly how you set it in ASRock, right? But let's try to run Prime 95 again, right? Prime 95 with 8 P cores with small FFT. There's no way I'm still boosting to 6 gigahertz. I'm actually still boosting to 6 gigahertz. Wait a minute. Why? I thought it would actually adjust thermal velocity boost. Maybe because it's enhanced thermal velocity boost. Maybe because of that. We'll see though. Let's see. Okay, apparently it's somewhere in between. Okay, I actually didn't know about this. That's kind of surprising, because when I usually set those frequencies in thermal velocity boost, it was just like when you set it to 5.3, it would set 5.3. But I think it's because of thermal velocity boost enhancement. So let me try and find out. Okay, let's find out together. How do you set it on Asus? I mean, technically, you could also do turbo ratios per core, but then you also need to disable the thermal velocity. There are multiple ways of doing it on Asus. Actually, no, that's not it. Thermal velocity boost, voltage optimization enhancement. All right, let's find out if it's enhancement. Do you think if I disable E-cores, I can pump more P-core? No. 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 They, like, the E-core and P-core are unrelated to each other. So like they are physically different cores, right? Let's find out. Am I still boosting to 6 gigahertz? We're still boosting to 6. Okay, never mind. Apparently we need wait, it's bugged. It's fully bugged because all the cores are boosting to 6 gigahertz. Asus, fix your BIOS. Oh my god. I wonder what this does. I think this actually just straight up locks the CPU to 5.3. We'll see. I wonder what also happens to voltage. That's kind of, I'm curious now. Well, let's see. 5.3, yes. Okay, so now we can actually continue with the discussion, right? Prime 95, let's see what happens to the P cores, right? If I lock it to 5.3, now the voltage adjustment should be automatic by motherboard. And I think it actually, yeah, it already adjusted the core voltage because I reduced the P core frequency. That means that the vid went down, and it's following the 5.3 vid, reducing the voltage. And let's find out. You know, it's kind of funny because I set a static core clock, right? It automatically would try to pull as much current as possible, right? So it's not adjusting per VF curve, it's adjusting per like, okay, so I'm trying to do static 5.3. So that results in a lower core clock because it's trying to draw a lot more current than it usually would. All right, that's kind of the, it's not a solution. You need to You need to limit the boost clocks, not the clock speed itself. If you log the clock speed itself, you actually are doing the wrong thing. You need to limit the boost clock. So, but I think the thermal velocity boost settings were bugged for me for the 5.3 in thermal velocity boost. Like, I'm gonna try it again. I'm gonna set this. Yeah. Sync all core auto. Wait, ratio limit. All right, okay. You might also do it here, but I think it's actually the same as setting a static core clock. One more down. Voltage optimization, overclocking enabled. Boost until target. Yeah, 5.3. Hello, 5300. Dude, I wish this works. So I can move on. I need to move on because we got another test. So like 288 limit plus 0.7 AC. Let's see. So no, we're still boosting. Oh my god, how do you do it on Asus N-Core? Like legit, actually, like I'm lost now. How do you do it on N-Core? I have no idea. I would assume that thermal velocity boost would actually do it because like I swear to god I did it on different boards and on Asus and it worked. It did like 5.3 boost. Here it's trying to boost more. What the hell do I do? Oh my, how do I limit boost on this? Anyway, I can internal CPU power management. So let's do 288 and let's kind of simulate a B760 board, right? 0.7. This is another mandate for CPUs that are experiencing the instability. There's definitely a way to do it. Yeah, maybe I need to use the stock BIOS to do it because this is a beta BIOS, beta overclocking BIOS. Maybe that's why I can't do it. So here we are back again at 6 gigahertz, and we can again start with a R15 with a overvolt, basically, right? With a overvolt. I almost don't believe it. Is it applying, by the way? Is it actually applying this? I don't believe it though. It is. It is applying because, but I think it's barely applying the AC load line. You know what's kind of funny? On Gigabyte boards, it's much more clear cut. It's kind of like boom. It's a fairly instant change in pretty much everything, like in the load voltage and boost voltage and everything. Here on the N-Core, there's barely any difference. I feel like the board is doing most of the work, to be honest. But it is applying. That's 100% sure. Yeah, so like the score is 5 less than before. That's kind of funny. That's hilarious. I want to hold on. I want to increase the AC load line a little bit more to 100. So like 1.1. Sorry, 1.1. Also, we're so like I loaded the BIOS profile. Now this BIOS profile has fast boot disabled and everything. So like I might as well disable that because if we're gonna be restarting the system so many times, might as well reduce it. 1.1. There. Can you try P and see which core crashes? I think P95 will just instantly close, Starblue. I think it will just instantly close. Like that's best case scenario, by the way, that the Prime 95 actually crashes one single core, or like let's say 2 if there's too bad of them. But usually it just instantly closes. Non-AVX large. True. You could do that. Yeah, you could do a prime test like that and see what happens. And you can also do it like this, right? So select 8 P cores, right? 8 P cores, I guess large, and disable AVX, and then boom, right? And then it will show you which torture test fails. Also like that is hilarious. But also this is a lot of voltage, so I might want to stop. Actually, by the way, a lot of voltage does not mean bad. A lot of voltage actually means that your current is not going to be that high, usually. So like, yeah, voltage does not result in current. Actually, low voltage is a lot of current. So that's the interesting part. If your power is still like very high. So let's say we're 1.3 here and 290 watts. If I was at 1.1 volt and 290 watts, that would be a lot of current, right? Anyway, benchmate. Now I wonder... Okay, this is kind of more like a B760. This. It still scores insanely well. Dude, my CPU is way too good. I'm sorry, dude. I'm sorry. I'm not showing real world scenario tests. My CPU is just way too good. Oh my god. It's not my fault. Shit. R15? 6, 1, 2, 3. I mean, we barely lost any performance, man. We didn't lose any performance. Jesus. Anyway, boom. 5.2 gigahertz load. 300 watts now. That's interesting. So you increase the IA-AC load line, you get higher power. Is it gonna score better? Oh no, it scores a little bit worse though, but it's so close. I think it's just the regulation, like the way that the board or the controller regulates the current threshold, I would say. I would say that this is related to like how the board behaves. I swear to God, if I put this CPU into a gigabyte board and I do the same thing, it's gonna behave differently. Asus runs on the spicy side. All of them will run on the spicy side if you unlimit it. Okay. Well, 979. Almost 980, to be honest. And 16322. So, again, we we lost barely any performance. Yeah, I think it's regulating performance, or I should say like the power and everything, the frequency. It's regulating it differently than other boards. And at the end of this, I will also show you what kind of stress test the Intel suggests you to run to actually fulfill the RMA process, right? Which is, in my opinion, kind of a joke. And I've already done it on previous streams, and I've shown the reliability of the stress test showing the instability. It is non-existent. I will wait for the second one. So like 927. Yeah, 920. Well, I guess 926. 926, again, barely any difference in performance by introducing more voltage to the CPU. And now VT3. I wonder how high can you run Intel tool before it spits an error. I can demonstrate that kind of. I can also demonstrate on stream what it looks like to have an unstable CPU, to show how useless it is. I can actually show that. I can show that by using IA-AC load line. Reducing the IA-AC load line, that's how. So 124 to 10. What was the previous one? 128. Again, barely any difference. Right, Handbrake. Do I even need to do this? I don't even need to do this. Like, you get the idea, right? Because this is gonna last like 6.5 minutes, and that's it. Might as well show you just like how the tool works, right? So this is the Intel processor diagnostic tool, right? You run it. Yeah, install it or whatever. I do not agree. Yeah, okay. Okay, close. Please use Windows Update to check critical updates. I do have. Processor diagnostic tool. So here you can see the diagnostic tool. Actually, no, I need to move it like here. So we get passes here. Yeah, it's hard to show this tool on screen like this. Tests running. This is gonna be interesting, by the way. because I actually don't know how much I can undervolt my CPU to start crashing in R15. I think it's at a very, very slight undervolt. I think it starts crashing at like 0.37 or something like that. We'll see. We'll see, obviously. But I actually wonder if it's gonna crash in the processor diagnostic tool. Another like very useless part about this is it doesn't stress test single core, especially P cores. Like if you have a power limit or a current limit, if you load up 2 cores, those 2 cores are going to be running at full boost. And potentially if you have a bad core, so let's say degraded core or something like that, if you hit that degraded core with a single core workload, it's gonna shit the bed, right? But if you start hitting the power limit by putting on a all core workload, all of the cores are gonna go down in frequency. So this would have to be, this stress test would have to be per core, right? Per core LIMPAC, and then show if it passes or not. But we'll see. So like I'll try to crash R15, and I'll try to crash Prime 95, and then run this diagnostic tool, and if it passes, that kind of shows you how useless it is, right? So that would be kind of like the awareness of what Intel is going to respond to you when you come to Intel and you describe your issue, right? I have an unstable CPU or whatever, unstable system. They're going to give you this stress test, and you're going to be able to accurately answer them, right? You're going to be aware that this stress test is kind of like not showing the real picture. That's the point. But do keep in mind, if you have a very degraded CPU, so for example, like a faulty core, right? A faulty core, this test, most likely it won't fail, but the PC will fail. So like you will get a blue screen or a black screen. So like your PC will restart. The test necessarily did not fail, but the PC failed, right? That's the more likely scenario that's gonna happen, because it happened on 2 samples for me, one 14900K and one 14700K, which I have a VOD of. I have a VOD and I have a clip of it. I can share the clip, or you can search for it in the clips. There is a clip of the CPU failing this test, and like literally the PC is shutting down when I was running this stress test. And here you can see like the pass, big green pass. Poggers, we've passed this test. Okay, now let's try and crash stress test, and let's try to pass this stress test to kind of like show if it's relevant or not. If it's relevant for applying for an Intel RMA, right? Because Intel will tell you to use this diagnostic tool to determine whether or not you can send the CPU back for RMA. If this passes, they can argue we are not taking the CPU back because the diagnostic tool tells us that it is stable, right? All right, let's unlimit this. Let's try to do an undervolt on it. So like 0.35. I think that's too much, but I'm just gonna do it. Yes. Thermal velocity boost. Yes, okay. Well, let's find out. Let's find out if I can crash R15 in before it starts passing R15, because the CPU is just that cracked. But I don't think so. I think it's gonna fail. By the way, do keep in mind, my CPU is so good that at stock it actually can sustain 5.8 gigahertz all-core frequency if it's unlimited. So it's actually sustaining higher boost frequency than the official spec. So like it might actually pass. It might pass this. We'll see. I hope it actually crashes, because that makes it faster for me. All right, let's find out. Okay, it crashes. This is exactly how an unstable CPU crashes. You see the first squares appear, you see a spike in load, and it just stops, and you can't do anything about it. Yeah, like the window is frozen. In that case, you can open this and you can close Cinebench, and you're back, right? You're back. Ooh, okay, so now let's run the CPU stress test or whatever it's called, right? The Intel CPU stress test. As you can see, 5.7 all-core right here. 5.7 all-core. You can see all of the details, and I can, I guess, lower a little bit so you can see the voltage as well. Yes, yes, yes. So this is like all-core workload. What is it called? Prime number. This is turning out to be a 2-hour... Like I said, this is gonna be like hours and hours and hours of talking and like demonstrating like how to go over this and what all the different scenarios might be like and everything like that, right? Like I said, it's not very clear cut. It's not very simple. It's not like, oh, my CPU is unstable. Oh, my CPU is not unstable. It's not that simple. As you can see, like the boost frequency is now almost 5.9 because it's a apparently it's a little bit a lighter workload. Float point, is it? Yeah, floating point. Almost 5.9. Yes, now we're testing what? We are testing math, apparently. We're testing math 5.7 full boost. And that AC load line reduction, right? That also tells you how close to the absolute maximum these CPUs are actually running, right? That gives you a very clear view that the stock AC load line on an i9 is pinned against the maximum possible stability of the CPU. So like obviously now the threshold of the degradation is very small, right? If your CPU degrades in an extremely small amount, you are already in the unstable range, right? Because your CPU is basically running completely maxed out, right? On the physical capabilities of the CPU. Here we can see CPU load. Apparently it's a more spiky workload. As you can see, like the power readout and possibly even voltage. No, voltage is kind of stable here, but you can see like the temperature a little bit spiking and the power is spiking as well a little bit. Now it's testing, yeah, CPU load. And then it's going to be CPU frequency, which I'm kind of curious about. All right, next stress test. Come on, come on, come on. All right, next one, pass. Perfect. Apparently, the Intel processor diagnostic tool says that my CPU is running perfectly fine while completely crashing. Oh, this is running, by the way. While completely crashing in R15 Extreme. Now I'm actually curious about R15. It instantly crashes. As you can see here, it was just a spike in load and it instantly crashes. And I'm actually now wondering about Prime 95. Prime 95. I can do small FFT. Let's see if the test crashes or closes. I'm actually curious. Okay, it completely blue screened the system. There you go. Meanwhile, the diagnostic tool tells me that my CPU is completely stable. That's how useless that utility is. So you can shut Intel up about their diagnostic tool and show them this. Everything else is going to be crashing. Your games are going to be crashing. Your software is going to be crashing. When you're going to try to use the CPU, everything is going to be crashing, but the utility won't. So yeah, there's your simple demonstration of how it looks like, right? And I think that covers pretty much most of it, right? This pretty much covers most of it, like the performance impact, which is about 10% with a current limit, right? And like everything that goes into this degradation and stability issues and everything and how to potentially solve them, right? There are 3 solutions to this if you are actually experiencing this issue. First is the current limit. Every board is going to have a different way of setting the current in the BIOS, obviously. Asus has it in internal CPU power management right here. I would recommend using 288 amps on all of them for daily usage, especially i9s, And also like keep in mind if you already have a CPU that has instability issues, then you have a second solution, which is limiting the boost clock of your CPU. Now, I would assume that every other Asus motherboard than Apex Encore would set this here. So like you would set 5.3 here and your boost will be set to 5.3. Thermal velocity boost is going to be set to 5.3. So that is the second solution, limiting your turbo boost multiplier, turbo boost frequency. The third solution would be increasing your IAAC load line. Now Asus does not show the stock load line of your CPU. Based on my testing, it was around 0.42. That is the stock value for Asus. It might be different per CPU, but that's just from my findings, my own findings. So anything over this, I would set like 0.6 or 0.7. That would increase your boost and all-core workload voltages. On Gigabyte, you have a value of 40 in the advanced voltage menu, near the bottom of the BIOS. MSI has light load mode called in advanced CPU settings. It's a light load mode, and usually the default value is 9. So you can increase that to like 11 or 12 or something like that. And this is specifically on Z790 chipsets. Specifically on Z790. B760 have a different IAAC load line. They have a much higher IAAC load line. Gigabyte, for example, has 70 compared to 40. Some of them actually have 90 compared to 40. Now, that's also depending on what kind of CPU you're using, right? Will 0.2 pass Intel tool? Maybe, possibly. Who knows? Probably. So that's the 3 mandates. But I would suggest contacting your retailer or Intel about the instability issues. Now, the answers that we got, the 2 answers that we got were the first one, trying to run the Intel diagnostic tool. That was the first one. If it passes, you're not going to be able to return the CPU. The second answer that we got from Intel was a description how to increase load line calibration on your motherboard. So Intel is aware of the issue. They are, based on that answer, I can assume that Intel is actually aware of this issue and they want to temporarily solve it by making you increase the load line calibration of your motherboard. So basically the CPU is now going to operate at higher voltages under load, resulting in you hitting the thermal limits or potentially power limits much harder, right? Your all-core frequencies are going to drop, right? Because you're going to be hitting 100 degrees a lot faster because of the higher voltage, resulting in you obtaining the stability back. But if your CPU is unstable, it's stuck, like, why are you not taking it back? I have an unstable CPU. If I sell this CPU to another person on the marketplace, what? They're gonna put the CPU in and they're gonna crash constantly. That's not acceptable. Hello? What the? No, that's not gonna work. So, like, take your CPU, take your broken CPU back. Right? I want a replacement. I want a CPU that is stable on stock spec. That's basically what your spec sheet says. But yeah, that's my thoughts on it. And yeah, that's basically 2 hours of going over the issue, right? I think I've shared most of the information that I know, that I'm aware of, and like how to get the issue, like how to know if you have this issue or not. But yeah, that's about it, I think. Like I said, like this is an ongoing discussion, because I just scraped the surface of it, right? So like explain how to get this issue out and potentially solve it for yourself, right? But there's like much more that goes into it, because this is just on an Apex Encore, right? An Asus motherboard. What about Gigabyte motherboard? What about different chipsets like B660, Z690, B760, Z790? on different BIOS versions and the different CPU generations for, like, example, 13900K and KS and then 14th gen. So like it is an extremely wide topic to cover everything, every specific detail about it. But I think I covered most of it so people can kind of like find their way around it and be aware of it. That includes the specific ways of running stress tests, specifically on P cores and crashing the P cores and everything like that. So like it includes pretty much everything, right? And all the relevant tests that I personally think will show the issue as fast as possible, right? As efficiently as possible. Right, because I don't want to introduce an incredibly difficult way of finding out if you have this issue. It's a very simple way of actually finding out if you have this issue. You run Benchmade and you run R15 and that's it. If it runs, perfect, nice. And then you run Prime 95. You set 8P core here, 8P core here, small FFT, boom. If it runs, perfect, amazing. It doesn't crash. None of the workers fail, so torture tests. Perfect, you have a good CPU, nice. Hopefully you set the current limit correctly, so you potentially don't risk the lifespan of your CPU, especially if it's an i9, right? But I would encourage you to actually keep hardware info open like this to monitor your core clock speed and temperatures and power consumption and everything, and including the voltage and everything. Now, keep in mind, that's also another specific thing. Voltage will, including the power readings and everything, they're gonna differ a little bit from board to board, right? Especially the voltage, because the voltage, it depends where the voltage sensor is coming from. Is it coming from on die? Is it coming from the I/O, the socket sense, the VRM sense? The voltage is gonna vary massively, right? But the more important parts are mainly the temperature and the power. Right, these are more important, right? That's about it.